Please let me know whether I am audible or not. Please let me know whether I am audible or not. We will start చేద్దామండి. Okay. So AP లో you all know that very big notification. Okay. In fact, మళ్ళీ లైఫ్ టైంలో ఒక ఎలక్ట్రికల్ ఇంజనీర్ ఎలిజిబిలిటీ ఉన్నవాడు లైఫ్ టైంలో ఇంత పెద్ద నోటిఫికేషన్ అయితే రాదు. This is the biggest notification we got. This is the biggest notification. Okay. So we are going to start with control systems previous year paper question solution. Okay. Previous year lo adigina prati question solve chestamu. Yes, we are going to solve each and every previous year question paper asked from control systems, asked from networks, other subjects, all other subjects like in fact technical, non-technical, everything, right? Yes. Yeah. So let us start. Control systems అనేది చాలా ఇంపార్టెంట్ సబ్జెక్ట్ అండి. కంట్రోల్ సిస్టమ్స్ నుంచి అట్లీస్ట్ ఇఫ్ యూ సే 70 మార్క్స్ ఇస్ టెక్నికల్, 7 మార్క్స్ అయితే గ్యారంటీగా వస్తాయండి. 7 marks are guaranteed from control systems. Okay. Yes, truly 7 marks are guaranteed from control systems, right? Let us start AP Transco AEE 2019. Okay. ఈ క్వశ్చన్స్ అన్ని ఇప్పుడు నేను సాల్వ్ చేసే క్వశ్చన్స్ అన్ని ట్రాన్స్కోలో అడిగాడు అనమాట. కంట్రోల్ సిస్టంలో వెరీ ఫస్ట్ టాపిక్ ఈస్ మ్యాథమెటికల్ మోడలింగ్. ఓకే. వెరీ ఫస్ట్ టాపిక్ ఇన్ కంట్రోల్ సిస్టమ్స్ ఈస్ మ్యాథమెటికల్ మోడలింగ్. ఓకే. మ్యాథమెటికల్ మోడలింగ్ ఫస్ట్ క్వశ్చన్ దాని నుంచేనండి. మ్యాథమెటికల్ మోడలింగ్, రైట్? ఫస్ట్ క్వశ్చన్ దాని నుంచి. లెట్ మీ రీడ్ ద క్వశ్చన్ అండ్ సాల్వ్ ఇట్, learn some concept also. Okay. In force current analogy, the mass m in a mechanical system is analogous to dash in an electrical system. What that fellow is saying is, force current analogy, we have two types of analogies. One is force voltage analogy. Yes, force voltage analogy. So in this, force is analogous to voltage. This is force current analogy. In fact, yes, this is force current analogy. Yes, this is current analogy. Okay, force current analogy. I will tell you how to remember easy ga ela gurtu pettukovali veetni anna vishayam kuda cheptanu. Okay, see, understanding is one part, but remembering is another part. One must be in a position to remember it meaningfully without confusion, so that he can tick for the answer without calculating or without wasting his valuable time in the examination. That is further more important, right? So force is analogous to current, means in mechanical system force is there that is equivalently analogous to electrical quantity current. Okay. Velocity is analogous to voltage. Okay, the name itself, force current analogy, force is analogous to current, velocity is analogous to voltage. These two you remember, remaining you can easily understand. Displacement means it is not distance and displacement both are not same. Displacement means one form of the distance only, but it is not exactly distance. Displacement is analogous to flux. Okay, flux linkage psi. Mass is analogous to capacitance. Damping coefficient is analogous to inverse of the resistance and conductance. Spring constant K is analogous to inverse of the inductance L or 1 by L, right? Newton's second law is analogous to Kirchhoff's current law KCL. As it is force current analogy, yes, it is KCL, right? Let's come to force voltage analogy, then I'll tell you how to remember it easily. Okay, this is somewhat a theory, raw topic. Next onwards it will be very beautiful and understandable, simple things. Okay, this is somewhat, people may feel it as somewhat heavy, but it is not that heavy. Force is analogous to voltage. Now force is analogous to voltage, we have current, then velocity will be analogous to current. Means in force current, here current, see, force current analogy, here it is current, here it is voltage, right? Displacement, this is psi, here it is q. You know concept of duality. Voltage is dual to current is dual to voltage. Charge is dual to flux is dual to charge. Yes, q is the charge, psi is the flux linkage. Mass m, There it is capacitance, here it is inductance. You see, there it is capacitance, here it is inductance. These two are duals. These two are duals. These two are duals. These two are duals. Okay, duality. If you know the concept of duality, one you remember, another easily you will get, right? There in force current, it is 1 by R, which is nothing but conductance. Conductance and resistance both are duals. Both are duals, right? Here, there it is 1 by L, here it is 1 by C. Yes, in force current analogy, it is 1 by L, right? 1 by L. There it is KCL, here it is KVL. Yes, KCL and KVL both are duals to each other. Here I covered the concept of duality also. Let me give you the statement of duality. What is why, sir, why all of a sudden you are coming from this force current and force voltage analogy to concept of duality? To remember meaningfully without confusion. Okay, what is dual? If you take any network, KVL equations of that network are exactly same as that of KCL equations of other network. Choose two networks, right? KVL equations for this, KCL equations for this. Okay, this KVL are mesh equations and nodal equations. More precisely to say, these mesh equations are, I can say, exactly same as that of these nodal equations. Then these two networks are said to be dual. Now we have dual pairs, like voltage with current is a dual, charge with flux, right? And resistance with conductance. Most of the people will misunderstand that resistance and conductance are as reciprocals, they are duals. Reciprocal, dual, both are not same. Now here what is the question? The question is, in force current analogy, mass M is analogous to what? That is analogous to capacitance in force current analogy. In force current analogy. In force voltage analogy, yes, mass is analogous to inductance. You need not to remember. That's what my point. Here it is capacitance. Now, what is the dual of capacitance? Suppose if it is force voltage analogy, right? Capacitance dual is inductance. Capacitance dual is inductance. That's all. That much simple question it is. If you have any question, you can type in the chat box. I will be answering your query, right? Let's go to the next question. That is all this is explanation. This document will be provided. Okay, you can join our free WhatsApp group, which is whose link is mentioned in the description box, right? You'll get this document with the full explanation, right? Now let's go to the next question. This next question, I guess it is from, yeah, what is the next question, right? As it is very I can say small diagram, let me draw it very clearly for you so that, yeah, it is visible for you. He given one signal flow graph. He is asking what is its transfer function. This is very simple thing. Apply Mason's gain formula. Okay, first of all, what is Mason's gain formula, sir? Mason's gain formula is used to find transfer function from any given signal flow graph and block diagram. Yes, we can find directly transfer function from block diagram using Mason's gain formula. Most of you will, what you will do is, you will convert the given signal flow graph, given block diagram into signal flow graph and apply Mason's gain formula. But for block diagram as well signal flow graph, directly we can apply Mason's gain formula. I repeat, for block diagrams also, Mason's gain formula is directly applied. Mason's gain formula is strictly applicable between input and output nodes only. If input node is not defined, Mason's gain formula is not applicable. Okay, output node is not defined, we can make it defined. If output node is not defined, there is no question that output node is not defined. Suppose, first of all, what is input node? The node which is having only outgoing branch is called as input node. What is output node? The node which is having only incoming branches. Now you see, let's understand the complete thing behind Mason's gain formula. According to Mason's gain formula, transfer function. What is transfer function? Laplace transform of output variable by Laplace transform of the input variable is equal to m1 delta 1 plus m2 delta 2 and so on. How many are there? Those many you have to take number of outputs by delta. m1 delta 1 plus m2 delta 2 and so on. mn delta n by delta. mn delta n by delta. Where, yes, I'm writing here m1, m2, M3, and so on are what? Forward path gains. What those are? Forward path gains. What is a forward path, sir? First of all, what is a forward path, sir? Let me underline here. Forward path gains. What is a forward path, first of all? Forward path is a path which is taken from input node to output node. Yes. What is a forward path? The path taken from input node to output node without touching any node for more than once. Yes, I repeat. Forward path is a path which is taken from input node to output node without touching any node twice in that particular forward path. Okay, so how many forward paths are there? First of all, input node. What is input node? Input node is also called as source node. Okay, input node is also called as source node. Output node is also called as sink node. Okay, right? And see, this is input node, the node which is having only outgoing branches. I repeat, the node which is having only, underline that only. It should not have both incoming and outgoing. It should have only outgoing branches. Yes, R is the node which is having only outgoing, input node. The node which is having only incoming branches is called as output node. Yes, C is the node which is having only incoming branches, right? R is input node, C is output node. How many number of forward paths are there? Yes, 2 forward paths are there. What are the 2 forward paths? This is the first forward path straight. So what is the first forward path gain? M1. First forward path gain is M1, right? First forward path gain is M1. How much is M1? How much is M1? 1 into 10 into 1, it is 10. 1 into 10 into 1, it is 10. Okay. See, that forward path gain is also called as a transmittance. In fact, overall transfer function value is also called as transmittance. Sometimes in some areas, we'll call it as transmittance, right? Now, forward path gain, the value associated for a particular forward path is called as transmittance. Okay, there's a word transmittance. One time in transco examination, transmittance, this word was asked in objective for 1 mark. Anyhow, every question is of 1 mark only in transco, Zenco, and all these examinations. Okay, first forward path gain is M1. Now, what is the second forward path? Second forward path, you have to choose R to this node, then from upside again to this node and go forward. So that is 1 into 5 into 1. How much it is? 5. 5 it is. How much it is? 5. Okay. Now, and sir, M1, M2 are okay. What is delta, sir? Delta is very, very, very important. Delta 1, delta 2. What is our formula? You can see the formula here. What is our formula? M1 delta 1 plus M2 delta 2 and so on, Mn delta n by delta. We got the clarification about M1, M2 and Mn and so on up to Mn. Now, first let's understand what is delta. Then delta 1, delta 2 are damn easy. Okay. See here, if you follow carefully, you'll be learning a lot of things, lot of shortcuts related to your examination. Okay. So any question, delta formula will start with 1. Any whatever with the diagram, it may be signal flow graph, block diagram, or any diagram. 1 minus, 1 immediately minus sum of all the loop gains, sum of all the individual loop gains. See, sum of all the individual, individual loop gains. Now here a question starts in your mind, sir, what is a loop? What is a loop? Loop is any closed path which starts and ends at the same point. But precaution, when you are forming a loop, no node should be touched for more than once except that starting loop. I repeat the statement. I'll execute that statement in fact here itself. Yes. You can, if you have any questions, you can type in the chat box. Loop is any closed path which starts and ends at the same node. It has to start at the node and it has to end at the same node. And in this loop formation, no node should be touched for twice. Obviously, first node where it is starting, again it is ending there only. It will be touched twice. It will be counted twice. Only starting and ending node, as it is the same, it will be counted for twice. But no other node should be counted twice in formation of the loop. Right now, how many loops are there here? This is crucial. People will commit mistake. Okay, so here I am starting. Observe, this total circle is a loop. What is that loop gain? When you are moving that loop, you will come across a lot of values associated with that branches. What is a branch? Branch is a connection between any two nodes. Branch is a connection between two nodes. Okay, when you are moving in that loop, there are some branches you are encountering. So those branches are having some values. That the value is called as transmittance. I told you. Okay, that is called as branch gain or transmittance. The value associated with a particular branch is called as branch gain or transmittance, as I told you previously. How many loops are there? First of all, number of loops. This is first loop. What is that loop gain? L1. L1 is equal to 5 into minus 2 is minus 10. That's okay, fine, sir. Sir, any other possibility of loop formation? Yes, this particular one is also a loop. Yes, this particular one is also a loop, right? How much that will be? L2 is equal to minus 20. L2 is equal to minus 20. So minus 10 minus 20, right? 1 minus sum of all the individual loop gains. Formula is not yet over. Plus, see, again, I'm saying the same thing, that is any question delta formula starts with 1. 1 minus sum of all the loop gains plus. So from here, people will feel it as complicated part, but I'll make it simple. Okay. I'll write the statement, then I'll teach that in reverse way. Okay, to understand. Sum of, yes, sum of the, whose sum it is? Product of, whose product it is, sir? Product of what, sir? Two non-touching loop gains. Non-touching loop gains. Next, close the bracket, minus. First of all, let's understand this. What is this, sir? See, first of all, you have to select two non-touching loops. What to do? What is a non-touching loop, sir? People will misunderstand non-touching loop just by looking at the physically touching, that is not required for this. See, simply I will take, or why to take very complicated, very simple diagram I am taking. Okay, just a minute. Right here, you see carefully. See, this is loop 1, first loop. This is second loop. This is third loop. All three loops are non-touching with each other. L1 is non-touching with L2. L2 is non-touching with L3. L3 is non-touching with L1. Right? Means what is a non-touching loop? Non-touching loop means, I'm not writing completely. Okay. Those loops should not have any node in common. Means common ga ఏ నోడ్ ఉండకపోతే ఆ loops non-touching loops అంటాము. Okay, so for better understanding purpose, let me take one more example, right? See, I want the answer for this question from you. How many two non-touching loop pairs are there? I repeat, how many two non-touching loop pairs are existing? I want from this, right? This is input R, this is output C, right? Output C. Then let me mark done. Now you see, first of all, if you start counting, you'll get here 5 loops. Okay, you'll get here 5 loops. This is loop 1, loop 2, loop 3. So these 3 anyone can identify. Those 3 loops anyone can identify. That's not a big deal to identify those 3 loops. But hidden loops are there which are not easily visible. Now this is also a closed path, you see. That is loop 4. This one is also a loop. Loop 5. Not done. We have another combination also. If you check, yes, from here, not possible to go, right? Yeah, from here you check, no, not possible. Yeah, 5 loops are there, for example. Okay, 5 loops are there. Now, sir, how to decide non-touching nature? How to decide non-touching nature? I will tell you. Sir, this is a node, this is a node. Both are side by side. Both are on the same line. Both are touching. No. This is a loop, sir. L1. L1 is a loop. L2 is also a loop. Sir, this is the L1 part. This is L2 part. Both are connected. Na? Both are touching. No. Suppose if you take this one as X, this one as Y, L1 loop is formed with help of the nodes X and Y. If you take a loop L2, L2 is formed with, let's take it as AB. L2 is formed with the nodes A and B. No node is in common. No node is in common. L1 is non-touching with L2. People will misunderstand, right? Sir, L1 and L2 are side by side only. Only one wire is connecting, or one signal or one branch is connecting L1 and L2. So we can consider that L1 and L2 are touching. No. So mostly people will get confused here. See why I am stressing here. When you're doing problems, you will misunderstand this way. Yes, when you do this, you will misunderstand this way. That's the reason why. That's the very reason why I'm taking this example. Touching means not a physical touching. Touching stands for nodes are common or not. That way you have to count. Now come here to our question. Now this is L1. This total is L1. This total is L1. Let's take this one as X, this one as Y. What L1 is formed with the nodes X and Y. Now let's write L2 is formed with the nodes what? Same nodes X and Y. So L1, L2 are touching with each other. There are no two non-touching loop pairs here. There are no two non-touching loop pairs here. Okay. Therefore, this part will be 0. Two non-touching loop pair itself are not there. Now minus sum of product of 3 non-touching loop pairs that never exist. See, 2 non-touching itself is not existing. There is no question of 3 non-touching. You can forget about it. 1 minus individual loop gains plus sum of product of 2 non-touching loops. I did not yet completed this explanation. What we have to do is, sir, take 2 non-touching loop pairs. Pair means what? Combination. Don't think only 2 are the pairs. Well, L1, L2 is a pair. Okay, that is 2 loops pair. 3 loops also will be a group or pair. Okay, don't go by English meaning. Okay, now what we have to do here is take 2 non-touching loops. Take those gains. Those gains you product. Suppose if L1 and L2 are non-touching with each other. In fact, that is not the case here. L1 and L2 are non-touching with each other. Take the value of L1 and take the value of L2. These 2 gains you multiply. Product. Here only one pair is there. Suppose if you are getting multiple pairs like that, all those you add sum of the product of the. So this way you have to come back. See, from back you have to understand. Take 2 non-touching loop pairs. Those gains you product. All such combinations you add. All such combinations you add. Sum of the what sum? Whose sum? Product of whose product? 2 non-touching loop gains. Now, so that way, sum of, yes, you have to continue with me. Sum of whose sum, sir? Product of whose product, sir? Product of 3 non-touching loop gains. Yes, 3 non-touching loop gains. 3 non-touching loop gains means first what we have to do, sir? Plus after that it will go with the 4 non-touching loop. First, what we have to do, sir? Take a 3 non-touching loop, take those gains, multiply that. How many such combinations are possible? You add that. But here, fortunately or unfortunately, 2 non-touching loop pairs itself is not possible. I'm writing its delta. For this one, delta is equal to 1 minus individual loop gains. Minus 10 minus 20 will be minus 30. Or for your understanding sake, I'm writing minus 10 minus 20. So delta is equal to 31. Okay, sir. We understood delta. We understood M1, M2, and delta very well. That's fine. What about delta 1 and delta 2? What about delta 1 and delta 2? You know, delta 1 and delta 2 are damn easy. I'm drawing that very same diagram once again for our ease of doing. Yeah, this is R, this is C. Yes. What are the values? I did not remember. 5, 10, minus 2. That's all. Okay. 5. This is 10. This is minus 2. I think sign is also important for us. One is, that is 5, 10, minus 2. Okay, sorry. I committed a mistake. This is 5, this is 10, this is minus 2. Right? Now, what is delta 1? Delta 1 is in the product with M1, right? Means delta 1 belongs to M1. M1 means what? First forward path. What is the first forward path? Yes, this is the first forward path we taken. What that fellow says is delta 1 is same as, yes, it is same as delta formula. Just now we learned delta formula, right? Same as delta formula, but by ignoring loops that are touching to first forward path, that are touching to first forward path. Why first forward path, sir? Because it is delta 1. Means this is first forward path. This total is L1. This is L2. Tell me, both are touching. L1, L2, both are touching to that first forward path. We have to ignore L1 as well as L2. If you ignore L1 as well as L2, what is delta? Formula delta is equal to 1 minus sum of the loops. No loop, no loop. Why? To this forward path. What is delta 1 formula? What is delta 1 formula? First of all, you already fixed the first forward path as this. When we calculated M1 as this is 1, I guess. 1, huh? Yeah, how much it is? 1 only. 1 and 1. Okay. Yeah, good. 1 and 1. Right. This is also 1. Now we already fixed our first forward path as that 1, 10, 1. 1, 10, 1. Right. Then we have to ignore or leave the loops which are touching to that fast forward path. What are the loops that are touching? Yes, L1 is this combination. This is happily, easily touching to this forward path. L2 is this combination. Let me mark here with a different color. L2 is this combination. This fellow is also touching with first forward path. What the scientist is saying, Mason is the scientist who given this formula. That's why it is called as Mason's gain formula. That fellow simply saying same as delta formula, but ignore the loops which are touching to that first forward path. Suppose if you are finding delta 2, yes, 1 minus second forward path. Any second forward path we have? We do not have. No second forward path, only one forward path. Or do we have second forward path? Any mistake I committed? No, second forward path is there, man. Second forward path is there. Sorry. This here arrow I taken in wrong way. No mistake I committed. Just arrow we taken in wrong way, which I'm correcting here itself now. Which I'm correcting now itself. Okay. This is the second forward path. Is there any loop which is non-touching to that second forward path? This is the second forward path. No. This first loop is anyhow part of that second forward path. This second loop is also having these nodes in common. Then also 1 minus no loop, that is equal to 1. Now C by R is equal to M1 is 10. Delta 1 is 1. M2 is 5. Yes, delta 2 is also 1. By delta is 31. So 15 by 31 is the detailed answer. Simplest answer. See, for your explanation, I explained for this much time. Otherwise, within one step, I can put his answer. No pen paper required for me for this question to answer. But my only motto is those who started their preparation, for them it must be useful in learning. That's why I taken completely. Here, total concept are given. What is input node? What is output node? What is a loop? What is a forward path? When the formation of forward path, and the formation of loop also, no node should be touched for more than once. What does it mean by 2 non-touching loops or 3 non-touching loops? Those loops should not have any node in common. That is the basic fundamental. People will see physically side by side. No, if you see that way, you'll get confused, you'll commit mistake. Never you can learn, right? Loops, suppose 4 non-touching loops I want. You select 4 loops such a way that no node is common between all these 4 loops. That is a 4 non-touching loop pair, right? Any question you have, you can put it in the chat box, right? Yeah, 15 by 31, simple question. This is a clear explanation is also given here. Clear explanation is given, but my explanation is far simple and understandable for you than the explanation that is typed over here. Okay, now there is a question given. The characteristic equation of a feedback system is given by SQ plus 13S squared plus 30S plus K. Which of the following statement is not true? He's asking about not true. See, that is a third order equation. For third order equation, I'm giving you one shortcut. ASQ plus BS square plus CS plus D is equal to 0. Where if you wanted to apply this shortcut, all A, B, C, D must be greater than 0. Then only you will be able to apply. I repeat. Okay, you will be able to. I'm solving this question with a shortcut. This question is from control system stability from Routh-Hurwitz. With Routh-Hurwitz criteria also we can solve. From same Routh-Hurwitz criteria, there is one simple shortcut. Many of you might be knowing it also. Okay, that is famous. Okay, now for in this format, third order, in this format, if there's a characteristic equation that belongs to a system, definitely that system must be LTI system. Otherwise, you can't apply that transfer function method of approach. And a characteristic equation is not valid, right? So transfer function, characteristic equation, all these are applicable for single input, single output system. System must be linear, system must be time invariant. Okay, and system must not have any initial conditions. That means with 0 initial conditions only you can apply transfer function method of approach, right? Now, for this one to be stable, see, for stability, the condition is BC, internal coefficients product. See, these two are external, this is internal. Internal coefficients product must be greater than external coefficients product, then system is said to be stable. Okay, then system is said to be stable, right? If, sir, what if this is case 1? Sir, what if these two are exactly equal? If these two are exactly equal, system is marginally stable. Do remember, when a system is marginally stable, it will oscillate or it is going to make sustained oscillations with some frequency. I repeat, if a system is marginally stable from second order onwards, I'm not talking about first order, which is having one pole at the origin, or one pole on an imaginary axis is not possible. Imaginary poles are always conjugates. Complex poles also always conjugates. I'm not talking about the case of one pole at the origin. If you have a transfer function like 1 by s, it is also marginally stable, but it is not making any oscillations. Its impulse response is a constant on it, either it is increasing or decreasing. But from second order onwards, means second order is also involved in it, included in it. In fact, if a system is marginally stable, it is going to make sustained oscillations. What does it mean by sustained oscillations? Sustained oscillations means whose magnitude is constant, means magnitude of the highest magnitude and lowest magnitude of the oscillations is constant, just like sine wave. Sine theta is making sustained oscillations, sine omega t is making sustained oscillations. Okay, not decreasing oscillations, not increasing oscillations. Okay, right? BC is equal to AD, system is marginally stable. If it is marginally stable, it is making sustained oscillations whose oscillations frequency is given by under root of D by B, which is also equal to root C by A. How, sir? D by B, get that B this side, that is equal to C by A, right? Third thing is, sir, what is the third possible case? BC is less than AD, then system is happily unstable. Unstable system is not happy, man. Just out of interest, I'm saying it is happily unstable. Unstable systems are useless. We can throw them outside. Okay, now let us see. Okay, upside. What is the equation we got here? Yes, let me write here, and just options are like 1330k. Okay, s cube 13s square 30s plus k is equal to 0. BC, how much is 13 into 30, to the best of my knowledge, it is 390, is greater than k. But from necessary conditions, k must be greater than 0. Yeah, k must be positive. Yeah, that is the condition. Na? A, B, C, D must be greater than 0. In place of D, bloody k is there. Right? 1 is greater than 0, 13 is greater than 0, 30 is greater than 0. In place of k, D is, in place of D, k is there. Now, if you combine these two, 0 less than k less than 390, system is stable. Now, sir, if k is exactly equal to 390, yeah, BC is equal to 80, na? BC is equal to 80, 390, system is marginally stable, and it is going to oscillate with some frequency. Omega oscillations is equal to under root of d by b. Bloody d by b, instead of d by b, I use c by a. Because c is 30, a is 1. If I do d by b, d is k, k is 390, I have substitute, cancel. Why all that nonsense? It will waste our valuable time, right? So 30 by 1, under root 30 is the frequency of the oscillations, right? The system is stable for 0 less than k less than 390, perfectly correct. The system oscillates for k is equal to 390, perfectly correct. The frequency of oscillations is root 30, that is also perfectly correct. The auxiliary equation in the Raoult's ablation is 13s plus 390. No, this is our answer, which is wrong. He's asking which one is the wrong statement. No auxiliary equation is possible here. Auxiliary equation is possible if your system is marginally stable. I repeat, auxiliary equation is possible if the system is marginally stable. Otherwise, no auxiliary equation. Right? Yes. I hope you are getting my points. Okay, right. Let's go to the next question. See, questions are damn easy. Okay, if you know the concept, you can directly tick for the answer. You can directly tick for the answer. Fourth question. The following is the time domain analysis method of control system. Nyquist is frequency response analysis. Yes, Nyquist plot, frequency response analysis. This is a direct question, no much explanation required. Bode is frequency response analysis. Nichols chart is also frequency response analysis, whereas root locus is time response analysis method. Sir, how? Means in Bode plot, in polar plot, in Nyquist, in Nichols, we replace S with j omega. In entire frequency response analysis means wherever you replace S with j omega, so that is frequency response analysis. If we keep S as it is as S, that is time response analysis, right? Or in this S is equal to what? Sigma plus j omega, right? That is time response analysis. Yes, Routh-Hurwitz criteria is also time response analysis. It is not frequency response method. Okay, time response or time domain analysis. Okay, let's go to the next question. What is saying? The transfer function known to be minimum phase of the system whose magnitude plot is shown in figure. Okay, Bode plot he given. Bode plot is given. He's asking what is the transfer function. He's asking what is the transfer function, right? I hope this diagram is not that clearly visible to you guys. I'm drawing it again, okay, for your visibility's sake. Okay. Now you see, initial magnitude is 40. That is gain in dB. This is 2. This is 10. These are called as corner frequencies. Corner frequencies are nothing but poles and zeros. Corner frequencies are the frequencies at which the slope of the Bode magnitude plot changes. This is minus 20 decibels per decade. Anyhow, this slope is 0 dB per decade. This is plus 20. It is not minus 20. This is plus 20 dB per decade. Right? Now, I'm writing transfer function. In fact, OLTF will be getting not CLTF, GH. Generally, we use OLTF for sketching the Bode plot, right? Initial, first of all, every transfer function is going to have some K. Yes, K is having, right? Initial slope is minus 20. If you see minus 20 slope, one pole, initial slope itself is minus 20. That pole is there at the origin. Now, at a corner frequency of 2, at a corner frequency of 2, that minus 20 became 0 dB. Minus 20 became 0 dB means somebody added plus 20. minus 20 became 0 dB means somebody added plus 20. Who will give plus 20? A 0. Will give plus 20? A 0. That is 1 plus s by 2. 0 means will be in the numerator, whole means in the denominator, right? Now that 0 dB became plus 20 means somebody who is sitting here added plus 20. Who will give plus 20? A 0 will give plus 20. Therefore 1 plus s by 10. 1 plus s by 10. Now option A is wrong, C is wrong, D is wrong, option B is the answer. You simplify it, you will get that way. Sir, it is not exactly same, not required. This k is a constant, it may be any value, it's not any value. We can get the value of k also from this very easily. But that fellow is least bothered about the value of k. That's why this 2k by 20 you will get. That also we can assume it as k. Right? But if you see remaining options, they are not at all fitting. They are not at all fitting. Their poles zeros, locations or placement of poles and zeros in the transfer function itself is wrong. That's why that remaining options are not correct. Right? Yes or not? Let's go to the next question. All this is explanation. As I told you, you'll be getting this document. Okay. Next question. What is saying? The unit impulse response of the system whose transfer function is. You want impulse response, unit impulse response. Okay. Impulse response, unit impulse response is simply inverse Laplace of the transfer function. Inverse Laplace of the transfer function. Just do inverse Laplace, you'll get the answer. But many people are not good at inverse Laplace. That's the bad thing. If you wanted to study control systems, you must be good at inverse Laplace and Laplace transforms. Otherwise, you can forget about control systems. Okay. The first topic itself to learn in control systems is Laplace and inverse Laplace. Okay. I'm keeping 3 aside. What I do is I'll add some 2 and subtract the same 2 from the numerator by s plus 2. Right. Inverse Laplace of 3 into s plus 2, split this way, s plus 2 by s plus 2 minus 2 by s plus 2, right? S plus 2 gone, it is 1. Now inverse Laplace transform of 3 into 1 minus 2 by s plus 2, right? So 3, inverse Laplace of 1 is del of t minus 2 into e power minus 2t into u of t will be the answer. 3 into del of t minus, yes, I'm writing over here. I'm replacing this space. Let's simplify it further. 3 del of t minus 6 e power minus 2t into u of t. In question, u of t is not mentioned. That doesn't matter. U of t magnitude is 1. What u of t tells us? U of t tells us that particular function is existing from t is equal to 0 onwards. Before t is equal to 0, that function value is 0. That's all, right? So most appropriate answer is not option A. It is option B, not C, not D. Okay. See this technique of adding plus 2, subtracting 2, that you should get. Okay. See, for your explanation, I am taking this much time. Otherwise, if you're good at these concepts, answering these questions will be of 30 seconds job, not more than that. Okay. If you are taking more than 30 seconds to answer these questions in your examination, I can simply tell you that you are wasting your valuable time in the exam, right? Question number 7. What is saying? The transfer function of a forward path of a unity feedback system is given by, if the point s is equal to some transfer function, that fellow given, which as of now I am least bothered until I complete that question statement, right? S is equal to J3 lies on the root locus for what value of k? See, if any point lies on root locus, this must satisfy. That is, magnitude of the transfer function must be equal to 1 if any point lies on root locus. That fellow himself saying that this J3 is a point which is lying on root locus with blinded eyes, with blindfolded, we can say that, we can take it. Because himself is saying, he confirmed it. You don't have to check for it if he confirms, right? If a point lies on root locus, it has to satisfy 2 conditions. One is magnitude condition, another is angle condition. This is the magnitude condition. Magnitude of the OLTF must be equal to 1. What is the angle condition? Angle of the OLTF must be equal to odd multiples of 180. Yes, but here for me, magnitude condition is required for me here. Why? Because he's asking for the value of k. Now what is k? K is equal to, keep k this side, take that all nonsense s into s plus 1 into s plus 9 to this side. Now put s is equal to j3. J3 magnitude is 3. J3 plus 1, root of 9 plus 1, root 10. Yes, root of 9 plus 81. How much it is? Root of 9 plus 81, 90, right? So k is equal to 3 into, from this also you get 3 common, root 10 into root 10 is 10. How much is 3 into 3? 9 into 10 is 90. K is equal to what? 90. Option is D for Delhi. As I told you, if you have any questions, you can type any question, you can type in the chat box, but none of you doing it. I don't know why. So you guys are feeling shy or fear or something to ask me a question in the chat box. I don't know. Okay. Next question. What is saying? The characteristic equation of a second order system, the system is, he given one second order characteristic equation, he is asking the system is of what type of damping. Compare this one exactly with this standard equation. If you compare these two, omega n square is equal to 9. So from this one, omega n is equal to 3. Okay. So 2 zeta, omega n is 3 already we got. What is the fun in writing again omega n? Time will be wasted, right? So zeta is equal to 1 we got. Zeta equal to 0, undamped, no damping, undamped. Zeta is less than 1 but greater than 0, that is called as underdamped. What is that? Underdamped. Damping is there, but it is less than 1, underdamped. Zeta is equal to 1, it is called as critically damped. Zeta is greater than 1, it is called as overdamped. So it is simply critically damped system. Why? Because we got the value of zeta as 1. We got the value of zeta as what? 1, critically damped. Next question. Okay. Next question is asking for the final value. What is final value theorem? Final value theorem in S domain says final value theorem. Final value is equal to, not theorem, theorem only, but final value is equal to limit s tends to 0. In time domain, final value means t tends to infinity. What is the reciprocal of time? Frequency. If time is tending towards infinity, frequency should tend towards 0. S into f of s, what is that? 2 into s plus 1 by s into s plus 3 into s plus 5 whole square, s gone, 2 divided by 3 into 25. Yes, 2 divided by, how much it is? 75. 2 divided by 75. Option is C for Chennai. Right? Direct question it is. Let's go to the next question. Now, this diagram is nothing to do. It was misplaced here. It was misplaced here. Please ignore this diagram. The previous diagram only, it got misplaced here. What is saying? DC servo motor, servo mechanism is not there in the syllabus. These are from old papers. Nah? DC servo motor, servo mechanism is going to have this transfer function. This way it is. So EB, induced EMF, is directly proportional to angular speed. Yes, induced EMF is directly proportional to angular speed omega. So E is directly proportional to omega omega B. Now if you remove that proportionality constant, some constant KB into omega B of t, apply Laplace, EB of S is equal to KB into omega B of S. That's all. Answer is KB. This is just worth of remembering. That's all. It is worth of remembering. Nothing more to understand in that. It's asking the polar plot of a transfer function g of s is equal to 1 by s into 1 plus st has intersections on apart from the origin. If you sketch this polar plot, initial angle itself is going to be minus 90 because one pole is there at the origin. This is minus 90 degrees. Final angle will be minus of 180, right? So this is minus 180 degrees. This fellow is going to, yes, minus 180. No, that is minus 270, right? That is minus 270. Okay. So this is minus 180. Never it is going to cross minus 180. This is the diagram. I drawn wrongly in the very beginning. This starting diagram what I drawn was wrong. Okay, omega is equal to 0. This is omega equal to infinity. Now let us see the options. They'll understand the question. Let us see the options. We'll understand the question. Neither the real axis nor the imaginary axis. Both. It is not going to intersect. It is not intersecting real axis. See, this is sorry. This is a real axis. This is imaginary axis. Neither it is intersecting real axis nor imaginary axis. Option A itself is perfectly correct. So at this kind of questions, people will get caught because mostly they won't practice how to sketch polar plot. Okay, that's why to make it tricky, they'll give this kind of questions. So when you are learning the concepts, you must habituate to sketch polar plot also. Then you will be able to answer these kind of questions easily, right? Without mistakes. Now, what's the next question? Let's see. Next question. What is saying? The unit steady state error. Okay, that fellow given. Okay, he's asking for ESS steady state error for what input? Step input. For step input, what is the steady state error formula? ESS is equal to A by 1 plus Kp. A is how much? 1. Why? Because it is of unit step. A by 1 plus Kp. 1 plus Kp. What is Kp? Kp is equal to limit s tends to 0 GSHS. What is that? 120 into s plus 2 by s plus 3 into s plus 4, right? So if you substitute it, how much you get? 2 times 2 60 times 3 20 times, I guess. Okay, Kp is equal to 20. 1 by 1 plus 20, that is simply 1 by 21. Option is B for Bombay. That is a formula. ESS is equal to A by 1 plus Kp. For ramp input, ESS is equal to A by Kv. For parabolic input, ESS is equal to A by Ka. A by Ka. The Kp is called as position error constant or coefficient, or step error constant or coefficient. Kv is called as velocity error constant or coefficient. Ka is called as acceleration error constant or coefficient, right? Let's go to the next question. So this is from AP EPDCL paper. Okay, he is asking the very first question from PD controller. When a PD controller is used in a system, which of the following is affected? PD controller means proportional plus derivative. Derivative means S term you will get KD into S. This is not going to change the type of the system. Type means number of poles which are present at the origin of an open loop transfer function. This is not going to change the type. Steady state error. This is not having much effect on steady state error. If the type of the system is changed, then error can be made equal to 0. It means if the type is increased, then the present type error can be reduced or made it equal to 0. Though it is not going to have, it is not going to change natural frequency, but in fact, it is going to change the damping ratio. So how it is going to change the damping ratio? I will tell you. See, this is a factor. Without a factor, this is omega n square by s into s plus 2 zeta omega n is the OLTF, without this. But when you keep this, that fellow also will come into picture. KD into S, KDS, that fellow will also come into picture. You get the characteristic equation 1 plus, this is OLTF. But this extra got added because of the introduction of PD controller. Then if you do this, your zeta is going to change. In fact, zeta is going to reduce. Damping ratio will be reduced, right? Okay, damping ratio will be affected, right? Next question is on compensators. Next question is on compensator. What is a lead compensator? Very simply, you can remember. Lead means to the origin, first there is a 0, next there is a pole. Means that fellow is given minus A should be here, minus B should be here. Means this is lead. Lead compensator is also called as differentiator. It is also called as high pass filter. If you sketch its Bode magnitude plot, you will get all that, why it is called as high pass filter, all that you will be understanding. This is lead compensator. Lag means near to origin, first there will be a pole, means Q, next there will be a 0, minus B. So magnitude wise, if you speak, B must be greater than A and P must be greater than Q are the conditions. B must be greater than A, or the same can be written as A is less than B and P must be greater than Q. A less than B and P greater than Q. Option is 3. Option is 3. AP, EPDCL paper it is. Okay. Next question, please. What he is saying, for a feedback control system of type 2, okay, the steady state error for ramp input will be, do remember type 0, see, type 0 system, or see, I'm giving step input to, see, step input I am giving to type 1, 2 and so on, steady state error will be 0. Ramp input I am giving to type 2, 3 and above, steady state error will be 0. Parabolic input, I'm not writing completely, parabolic input I'm giving from type 3 onwards, 3, 4 and so on, steady state error will be 0. What is saying? Ramp input to type 2, ramp input to the type 2, steady state error will be exactly 0. Directly you can mark it, means as I'm telling you, you can save your valuable time in the examination. Many people come and complain that time is not sufficient, paper was lengthy, too many questions. Nothing. Every question is prepared in such a way that if you know or if you have the right set of the concept, yes, I can say and answering that question is going to be damn easy if you have right set of the concepts with you. Okay. Yes. Any questions? None of you typing anything in the chat box. That is the main issue. Okay. If you have any sort of doubt in your mind, yes, I'll clarify here. Right. Next. There's the next question. This fellow is asking about synchro. Yeah. Synchro can be used as transducer. Amplidyne and metadyne, these are amplifiers. Right. Servo can be an activator. RC network is a compensator. We know this. You can remember this. Synchro can be a transducer. Okay. Servo motor generally will be used as activator. Activating means providing some mechanical input. Okay. Amplidyne, metadyne, these kind of things are amplifiers. RC network is simply a compensator. RC network, if you are taking voltage across capacitor as the output, it will be like compensator. If you are taking voltage across resistor as output, that will be lead compensator. Okay, that's bloody theory. Okay, yeah. Consider unit step response of a unity feedback control system whose open loop transfer function, the maximum overshoot. Yes, he given OLTF, but what is overshoot formula? MP is equal to e power minus pi into zeta by root of 1 minus zeta square, right? So for that zeta is needed. So how much is zeta? If you want zeta, you need characteristic equation. What is characteristic equation? 1 plus 1 by s into s plus 1 is equal to 0. So characteristic equation is equal to s square plus s plus 1. Now zeta is equal to 1 by 2 root 1, that is equal to 0.5. Sir, how you wrote this? Compare with the standard equation s square plus 2 zeta omega n s plus omega n square. You'll get that. Now MP is equal to e power minus pi into 0.5 divided by root of 1 minus 0.5 square. Yes, sir, in my examination calculator is not allowed, then how to do it? Yes, not possible without a calculator, because exponential power, roots and all, I know that yes, it is difficult. But look at the options. From options also you can't answer this question, because all options are less than 100%, right? Less than 100%. Okay, and it is not even 0. Okay, so if there is a peculiarity in options, we can identify, but here somehow you have to calculate. You must be very good at calculations, otherwise it is not possible. I repeat, you must be very good at calculation, otherwise it is not possible for you to do this, to solve this kind of questions, right? Answer will be 0.163. if you want in percentages, 16.3, right? Next question, please. What is saying? Yeah, a system is described. Somebody asked, sir, whether should I, as in the syllabus, a state variable model is not mentioned, should I skip? No, State variable model is very important. I think in syllabus it is there. Check it once clearly. Okay. A system is described with the state equation x1 dot x2 dot state transition matrix. What is state transition matrix? E power at, that is equal to L inverse of Si minus A whole inverse. Okay, L inverse of Si minus A whole inverse. What is that? L inverse of Si S0 0 S minus A is 2002, right? So L inverse of this is whole inverse also we have to do S minus 200. This is S minus 2, S minus 2. First of all, we have to do 2 by 2 matrix inverse. L inverse of 2 by 2 matrix inverse 1 by AD minus BC 1 by S minus 2 whole square, right? 1 by S minus 2 whole square. Exchange these positions, but both are same. Even with exchange also we'll get the same thing, nothing to do, right? And you have to put minus here, minus 0 plus 0, both are same. Therefore, let's keep it as it is, because as it is not changing even after calculation also, right? Divide it, you will get 1 by S minus 2 means e power 2t inverse Laplace. This is 0, this is 0, this is e power 2t. 1 by S minus 2 Laplace is inverse Laplace is e power 2t. So e power plus 2t, it is e power plus 2t. E power plus 2t. Yes, option is 4. That fellow is saying e power plus 2t 0 0 e power plus 2t, right? Yes or not? Yeah. Let's go to the next question. What this fellow is saying. A unity feedback system has open loop transfer function. Okay. Nyquist plot. How many times a Nyquist plot is going to encircle the origin? You know, these questions are mostly from gate examination. These questions are mostly from gate examination. Okay. Now, don't try to sketch Nyquist plot. It is waste of time. N is equal to P minus Z. N is equal to P minus Z, where N is number of encirclements with respect to origin. With respect to origin, right? With respect to origin, if you are taking characteristic equation, okay, if you are taking characteristic equation, if you take OLTF, those encirclements are with respect to the critical point minus 1, critical point minus 1, right? What is P? P is number of open loop poles in RHP. P is equal to 1. Z is number of closed loop poles which are in Z is number of closed loop poles in RHP. Closed loop poles in RHP. How to get that, sir? Apply Routh-Hurwitz. Instead of sketching Nyquist plot, apply Routh-Hurwitz. Okay, get the characteristic equation. What is that? S minus 1 into S plus 2 into S plus 3 plus 1 is equal to 0. S square plus 2S minus S minus 2 into S plus 3 plus 1 is equal to 0. So S square plus S minus 2 into S plus 3 plus 1 is equal to 0. Is equal to 0. So what is this? S cube plus 3S square plus S square plus S cube plus 3S square plus S cube, sorry, S cube plus 3S square done. S square plus 3S minus 2S minus 6 plus 1 is equal to 0. So x cube plus 4S square plus S minus 5 is equal to 0. Apply Routh-Hurwitz. You can't apply shortcut for this. Why? Shortcut is not applicable because see, this condition failed. Necessary condition itself is failed. Shortcut is not applicable. So this is 1 1 0 1 1 0 4 minus 5 0. How much is this? Is plus, this is plus 4 minus of minus 4 plus 5 by 4. Some positive only. Some positive only. Last element will be, somewhere we committed mistake. Last element will be minus 5. Yes, minus. How many sign changes are there? One sign change. Number of RHP is equal to 1. So N is equal to P is 1 minus Z is also 1. So N is equal to 0. For 0 times it is going to encircle. But here that fellow given it as 1. Z N is equal to P minus Z. It is not Z minus P. Z minus P is also correct. One is in clockwise, another one is in anti-clockwise. Okay. Let me check the calculation. P is equal to 1, number of poles with respect to origin are 1. Very clear. Very clear. Okay. And number of poles, open loop poles, and Z, number of closed loop poles in RHP. We got it as 1 sign change. Yes, maybe here something is wrong. Z is 0. It is not, Z is not equal to 0. Leave it off. Leave it off. Our explanation is perfect, right? Now here, as I told you in the very beginning, we can apply directly Masson's gain formula for the block diagram. Now C by R is equal to number of forward paths. How many forward paths are there? Only one forward path. G1, G2 into delta 1 by delta means what? 1 minus. How many loops are there? This is a loop. What is that? G1, G2, H1. At minus it is stopping here. So minus, sorry, it is minus G1, G2, H1, right? It is minus G1, G2, H1, right? Another is minus G1, H2. Those poles are touching with each other. Delta 1 is 1. So it is simply G1, G2 by 1 plus G1, G2, H1 plus G1, H2 plus G1, H2. G1, G2 by 1 plus G1, G2, H1. G1, G2, H1, G1, H2. Option is 4. Option is 4. See, none of you answering man in the chat box. I don't know what happened. All this is not required. Okay, just by applying Mason's gain formula. Okay. Next question. What is saying? A unit feedback system G of S is equal to the steady state error with ramp input. See, ramp input steady state error. You want what is the formula? ESS is equal to A. He said nothing. He told about ramp. No. He said ramp of magnitude 5. Actually, ramp is not going to have magnitude. Ramp will have slope. Okay. A by kV. A is 5 by kV. What is kV, sir? kV is velocity error constant or coefficient. Okay. A ramp error coefficient or constant. Limit S tends to 0. S into GSHS 40 into S plus 2 divided by S into S plus 1 into S plus 4. S gone. 40 into 2, 80 divided by 4. That is equal to 20. That is equal to 5 divided by 20. That is 1 by 4. Simply that is 0.25. Option is 1. Option is 1. Simple question. So all questions are damn simple if you are in a correct position to answer these questions. All questions are damn simple, right? So this way, all the questions we will be solving from all other subjects also. This way, we'll be solving all other questions from all other subjects also. Stay tuned. The next, I can say, subject that is going to be live on YouTube is the next subject that is going to be live on YouTube is electrical machines and power electronics. Electrical machines and power electronics. If you see, all these questions are damn simple questions. All these questions are damn simple questions. Okay, we solved more than some 40 questions if you observe, right? Every question is very simple if you know the concept, and every question is of a matter of 30 seconds, not more than that. Especially, see, the scoring subjects in these competitive examinations are networks, control systems. These are scoring subjects, and deciding subjects are machines, power systems. More number of questions will appear from machines and power systems, but control systems is having very good weightage. I'm not saying control systems is having equal weightage to that of machines and power system, but still it is significant. It will decide your selection. Okay, and see, if you have any questions, you can type in the chat box. Okay, we are going to start a dedicated live batch from 1st of July, practice questions batch. Okay, only practice means. But today I taught you all the concepts very clearly with respect to these questions: Mason's gain formula and force current analogy, right? Touching, non-touching, and all these things, right? In the same way, more detailed manner, we'll be learning in our live classes. Okay, if you have any queries, you can contact us on the given number that is mentioned in the description box, right? Any questions you have, last 3-4 minutes I will be dedicating for the questions. Any questions you have, you can ask. Any questions? Okay, all the best. Okay, you can join our free WhatsApp group in which you will be getting a lot of content, free content. It is absolutely free. Okay, all these questions along with the solution we will be putting in that free WhatsApp group. Okay, that document you will be receiving today itself. Just after completion of this session, you will be getting that, right? Very much useful content. Okay, all previous year paper questions will be solving on YouTube live, on YouTube platform on live. Okay, thank you. All the best.